Alright, welcome back. Block and file storage, EBS, EFS, FSX, storage gateway, Snow family, what it is, when to reach for it, and the one mistake everyone makes, rolling. By the end of this video, you'll know exactly which Amazon Web Services storage service to pick when S3 isn't the right answer, and there are more situations than you might think. S3 is brilliant for objects, but it can't be a boot disk for an EC2 instance, it can't be a Windows file share, and it definitely can't help you move 200 terabytes from a data center when your upload would take 6 months. 5 services fill those gaps, and one more ties them together for backup and compliance. Confusing them costs Code Gorilla's clients real money every week. In episode 19 we went deep on S3, the 7 storage classes, lifecycle policies, and that famous 11 nines of durability. S3 is object storage, accessed through an API, with effectively infinite scale. But today we're looking at all the jobs S3 simply cannot do, and the family of services Amazon Web Services built to fill those gaps. 5 terms before we get into the mechanics. Amazon EBS is block storage that attaches to a single EC2 instance inside one availability zone. Think of it as a virtual hard drive. Amazon EFS is a managed NFS file system for Linux, multi-AZ by default, and shareable across thousands of clients at once. Amazon FSX is an umbrella for 4 managed third-party file systems: Windows File Server, Lustre, NetApp ONTAP, and OpenZFS. Amazon Web Services Storage Gateway is a hybrid bridge that presents cloud storage to your on-prem applications using familiar protocols. And the Amazon Web Services Snow family is a set of physical devices Amazon Web Services ships to you when your data is too big to send over the network. Here's the thing about S3, it's incredible at what it does, but it's object storage. You can't boot an EC2 instance from it. You can't mount it as a Windows file share for an old SMB application. And you can't FedEx 200 terabytes of on-prem video footage into S3 over a network connection that would take half a year to upload it. Every service we cover today exists because S3 simply cannot do its specific job. So the question is never which one is best, it's which one fits the scenario. Here's the whole video on one slide. If you need block storage attached to a single EC2 instance, a boot disk, a database volume, that's EBS. If many Linux clients need to share the same files over a POSIX file system, that's EFS. Windows SMB, Active Directory integration, or high-performance computing, those go to one of 4 FSX flavors. When an on-prem application needs cloud-backed storage but expects familiar protocols, Storage Gateway is the bridge. When you have too much data to push over the network, the Snow family ships a physical box. And when you need one backup policy across many of these services, Amazon Web Services Backup is the answer. We'll spend the rest of the video unpacking each of these. Let's start with EBS. The mental model is simple. EBS is a hard drive bolted inside one specific laptop. Only that laptop can use it. You format it, you mount it, you install an operating system on it. It behaves exactly like a physical disk, because that's what it's emulating. EBS lives inside one availability zone, and it attaches to exactly one EC2 instance at a time. That single-tenant design is why it's cheap and fast, and it's also why we need other services for everything else. EBS comes in 6 volume types, and the shortcut is the workload shape. On the SSD side, GP3 is the modern balanced default, exactly 20% lower price per gigabyte than the older GP2, and it lets you tune IOPS independently of size. IO1 and IO2 are the premium tier for transactional databases that need the highest IOPS, with IO2 adding 5 nines of durability over the older IO1. On the HDD side, ST1 is throughput optimized for big sequential scans like log processing, and SC1 is the cheapest cold tier for data you rarely touch. The rule of thumb: small random reads and writes go to SSD, Big sequential scans go to HDD, and HDD volumes can't be boot disks. Read that line from the Amazon Web Services docs carefully. EBS volumes are automatically replicated to protect you from the failure of a single component. Notice what it doesn't say. It doesn't say replicated across availability zones. The replication happens inside one AZ, between disks and racks. If that entire AZ goes down, your volume goes down with it. This is the single most misunderstood fact about EBS. EBS replicates within a single availability zone. That's a deliberate design choice. Keeping the replicas close to the instance is what gives EBS its low latency block attachment. The trade-off is that cross-AZ durability isn't built in. Snapshots are the tool for that. They move point-in-time copies of the volume into S3, which is itself replicated across AZs. So the mental model is EBS for fast attached storage, snapshots for durability beyond the AZ. This distinction catches engineers who assume EBS matches S3's cross-AZ replication, because so many other Amazon Web Services do. Here's how EBS escapes its AZ. Your volume sits in AZA, attached to one EC2 instance. That's the fragile part. When you take a snapshot, Amazon Web Services sends a photocopy of every block into a managed S3 bucket, and once it's in S3, it inherits 11 nines of durability and replicates across every AZ in the region automatically. From that snapshot, you can restore the volume into a different AZ in the same region, copy it cross-region for disaster recovery, or copy it cross-account into a hardened backup vault. And snapshots are incremental. Only the changed blocks get sent after the first one. So the volume itself is fragile, but the backup mechanism is not. Even with snapshots, EBS has one fundamental ceiling. A volume attaches to exactly one EC2 instance. The moment you have a second instance that needs to read or write the same files at the same time, EBS cannot do that job, and that's where EFS comes in. If EBS is the hard drive bolted inside one laptop, EFS is the shared network drive in the office. Everyone mounts the same folder at the same time. EFS is a fully managed NFS file system for Linux. POSIX compliant, multi-AZ by default, and elastic. It grows and shrinks as you add or delete files, no provisioning required. And you can mount it concurrently from thousands of clients. EC2 instances, ECS tasks, EKS pods, Lambda functions, Fargate containers, they can all see the same file system at the same time. Straight from the Amazon EFS documentation, compute instances running in multiple availability zones can access the file system. So many users can share a common data source. 2 facts to anchor: multi-AZ access and many users sharing one source. That's the entire reason EFS exists, and it's exactly what EBS cannot do. Here's the slide that decides architecture and budget. On the left, EBS, one instance, one AZ, block-level virtual hard drive, around 8 cents per gigabyte month for GP3. Boot disks and single-node databases live here. On the right, EFS, thousands of Linux clients at once, multi-AZ by default, an NFS mount point, and around 30 cents per gigabyte month. That's roughly 4 times the price per gigabyte. The right reason to pay that premium is shared access. The wrong reason is convenience. Here's the cost reality. EFS sits at roughly 30 cents per gigabyte month on its standard tier. EBS GP3 is around 8 cents. That's about a 4 times premium, and you're paying it for one specific capability, concurrent access from many instances over NFS. When the workload genuinely needs that shared file system, the premium is justified and EFS is the right call. When a single instance is doing the work and no sharing is required, EBS is both cheaper and the architecturally correct choice. The decision comes down to access pattern, not convenience. Now, EFS is great for Linux, but it's only Linux. The moment you need Windows, or high-performance computing, or a NetApp environment, you need FSX. FSX is an umbrella brand, 4 completely different third-party file systems, all fully managed by Amazon Web Services. FSX for Windows File Server speaks SMB and NTFS, and integrates with Active Directory. FSX for Lustre is a parallel file system built for high-performance computing, capable of hundreds of gigabytes per second of throughput. FSX for NetApp ONTAP is a multi-protocol enterprise file system that supports NFS, SMB, and ISCSI, plus SnapMirror replication and deduplication. And FSX for OpenZFS is low-latency NFS with ZFS-style snapshots and clones. Here's the keyword to variant map. If the scenario says Windows, SMB, or Active Directory, pick FSX for Windows File Server. If it says high-performance computing, machine learning training, or hundreds of gigabytes per second of throughput, that's FSX for Lustre. SageMaker training jobs often use Lustre as a high-speed cache in front of S3. NetApp, ONTAP, or SnapMirror in the question stem points to FSX for NetApp ONTAP. The fourth box, OpenZFS, is the one to choose when you see writable clones or sub-millisecond latency targets in the requirements. One architectural constraint to know: 3 of the 4 variants support multi-AZ deployments, but Lustre is single AZ by design. Lustre's performance model depends on tight network coupling within 1 AZ to deliver sub-millisecond latency for HPC workloads. That means Lustre is unsuitable when the architecture requires cross-AZ failover. Now we shift from cloud-only storage to hybrid scenarios. Storage Gateway is the front desk of your old office that secretly forwards every package to a giant warehouse in Amazon Web Services. It runs as a virtual appliance in your on-prem data center and presents Amazon Web Services storage to your existing applications using protocols they already speak. NFS, SMB, ISCSI hot data gets cached locally for low latency, but the source of truth lives in Amazon Web Services. That means you can migrate gradually without rewriting legacy applications that hard-code network paths. 2 of the 4 storage gateway flavors handle file protocols. S3 File Gateway accepts NFS or SMB and stores the files as objects in S3. Great for shifting a Windows or Linux file share into the cloud. FSX File Gateway also speaks SMB, but it caches data from FSX for Windows File Server, giving on-prem users low-latency access to a Windows file system that actually lives in Amazon Web Services. Worth knowing it exists, though Amazon Web Services has closed it to new customers, so recognize the name but don't propose it for greenfield designs. Volume Gateway presents ISCSI block storage to on-prem servers, storing data as EBS snapshots in S3, useful for block-level backup of on-prem workloads. And Tape Gateway emulates a virtual tape library over ISCSI, backing tapes into S3 Glacier or Deep Archive. We'll unpack that one next. Tape Gateway is worth pausing on because it solves a specific real problem. Imagine a regulated financial firm running VM or net backup pointed at a physical tape library, with a tape robot that has to be maintained, replaced, and stored in a fireproof vault. You swap the physical library for Tape Gateway, and the backup software sees the same ISCSI virtual tapes it always did. But those tapes now land in S3 and automatically tear down to S3 Glacier Deep Archive. The backup application never knows the difference. The physical tape robot is gone. The compliance retention is satisfied, and the storage cost drops by orders of magnitude. These two get confused all the time, so let's pin them down. Storage Gateway is an ongoing hybrid connection. Data keeps flowing both ways. It runs over your network, and it acts as a protocol bridge so legacy applications keep working. The Snow family is offline by design, for situations where your network simply can't keep up. It's a one-time bulk transfer, Amazon Web Services ships you a physical device, you load it, and you ship it back. Storage Gateway is steady state. Snow is a migration project. Different problems, different tools. There's an old engineering joke: never underestimate the bandwidth of a station wagon full of tapes. The Snow family is Amazon Web Services taking that joke seriously. These are ruggedized devices Amazon Web Services ships to your site, so you can copy data onto them and ship them back. Used when uploading over your network would take weeks or months. Snowball Edge is the current workhorse. The storage-optimized model now ships with 210 terabytes of high-performance NVMe storage. You also see Snowcone and Snowmobile in study materials. Snowcone came in an 8 terabyte hard disk version and a 14 terabyte solid-state version, and Snowmobile was a 45-foot semi-truck holding 100 petabytes. Amazon Web Services retired Snowmobile in early 2024 and discontinued Snowcone in November 2024. So recognize both names but don't recommend either for new architectures. There's also a compute-optimized Snowball Edge variant that can run EC2 and Lambda locally for edge processing. Here's the entire Snow decision rule in one sentence. If uploading over your internet pipe would take longer than shipping a hardened box, the box is the faster network. A research lab with 200 terabytes of sequencing data and 100 megabit uplink will ship 2 Snowball Edge devices rather than wait 2 months for an upload. The math is simple, and it's the only thing you need to evaluate. Read that second sentence carefully. Data transfer into Amazon S3 is free, so when you're using Snowball to migrate data into Amazon Web Services, you pay for the device and for any data going out, but the inbound data transfer itself costs nothing. This catches people off guard. The asymmetry is, data going into Amazon Web Services via Snowball is free, but if you're using a Snowball to export data out of S3, you pay standard S3 egress rates. In equals free, out equals charged. Now, every service we've covered has its own backup mechanism. EBS has snapshots, RDS has automated backups, DynamoDB has point-in-time recovery, EFS has its own backup. That's a lot of separate consoles, separate schedules, and separate retention policies, a nightmare for an auditor. The centralized backup service is the universal remote. You define one policy with one schedule, one retention period, one encryption setting, and the service orchestrates backups across EBS, EFS, FSX, RDS, DynamoDB, S3, EC2, and more. It also handles cross-region and cross-account copies through organizations, which is the standard pattern for disaster recovery vaults. The phrase that matters in the official definition is centralized, policy-based, and in a compliant manner. When a scenario describes a compliance officer who wants one place to define and audit backup policy across many services, that's the cue for the centralized backup service, not the native snapshot tool of each individual service. And remember, the service doesn't back up anything until you assign resources to a backup plan. No plan means no backups, no matter how many services it could theoretically protect. Here's the whole episode as a keyword lookup table. Single instance, block disk, or boot volume goes to EBS. Linux with shared NFS or POSIX access across many instances is EFS. Windows, SMB, or Active Directory is FSX for Windows. High-performance computing, machine learning training, or hundreds of gigabytes per second is FSX for Lustre. An on-prem application that needs cloud storage over NFS, SMB, or ISCSI is Storage Gateway. Retiring a physical tape library is Tape Gateway specifically. Petabytes with limited bandwidth and an offline shipment is Snowball Edge. And a single backup policy across many services for audit is Amazon Web Services Backup. Find the keyword in the question stem, and the service falls out. 3 misconceptions worth burning out of your mental model before exam day. First, EBS does not replicate across availability zones. The The replication happens inside one AZ. Only the snapshots, which stored in S3, give you cross-AZ portability. Second, you cannot share one EBS volume across multiple instances as a cheap substitute for EFS. Multi-attach exists for clustered databases like Oracle RAC, not for general file sharing. Third, Storage Gateway is specifically for hybrid scenarios where on-prem applications need to reach cloud storage. It is not for storage that already lives entirely in Amazon Web Services. 5 things to lock in before we test what you've absorbed. 1. Single instance and block disk goes to EBS. Many Linux clients goes to EFS. Windows and SMB goes to FSX for Windows. 2. EBS lives in one AZ, and snapshots in S3 are how you get cross-AZ and cross-region durability. 3. FSX is 4 file systems under one brand, so match the keyword to the variant. 4. Storage Gateway is ongoing hybrid, Snow is a one-time bulk shipment, and Snowball data going in is free while data going out is charged. 5. Amazon Web Services Backup is your single pane of glass for backup policy across many services. Now let's see how well that landed with a quick 5-question quiz. Alright, time to put your knowledge to the test. Question 1. A team is running a single-node PostgreSQL database on an EC2 instance. They need the lowest possible write latency and the highest durability guarantee for a transactional workload. Which EBS volume type should they choose? Option A, ST1, throughput optimized, HDD. Option B, SC1, cold HDD. Option C, IO2, provisioned IOPS SSD, or option D, GP2, general purpose SSD. Pause here if you want more time. The right call here is C. IO2 is the provisioned IOPS SSD, delivering the highest IOPS and 5 nines of durability, exactly what a latency-sensitive transactional database needs. HDD volumes like ST1 and SC1 are for big sequential scans, not random reads and writes, and GP2 is the older general-purpose SSD, fine for many workloads, but it lacks the IOPS ceiling and the durability guarantee of IO2. Question 2. A fleet of 40 Linux EC2 web servers behind a load balancer all need to read and write the same uploaded media files concurrently, and the system must survive an availability zone outage. Which storage service fits? Option A, Amazon EFS. Option B, Amazon EBS with multi-attach enabled. Option C, Amazon S3 mounted as a block device. Or option D, FSX for Windows File Server. Lock in your answer before I give it away. It has to be A, and here's why. EFS is the managed NFS file system for Linux, multi-AZ by default, and built to support thousands of concurrent clients reading and writing the same files. EBS multi-attach is restricted to one AZ and exists for clustered database applications, not general file sharing. S3 isn't a file system you can mount as a POSIX volume, and FSX for Windows is the right answer for SMB workloads, not Linux. Question 3. A research lab has 200 terabytes of genomics data sitting in an on-premises data center with a 100 megabit per second internet uplink. They need this data in S3 within 2 weeks. What's the most appropriate approach? Option A. Use Amazon Web Services Storage Gateway in File Gateway mode. Option B. Upload directly to S3 using the Amazon Web Services CLI with multipart upload. Option C. Provision Amazon Web Services Direct Connect and stream the data. Or option D. Order an Amazon Web Services Snowball Edge device. Run the decision rule from earlier before you answer. If you said D, well done. At 100 megabits per second, 200 terabytes would take roughly 2 months to upload, far longer than the 2-week deadline. Storage Gateway is an ongoing hybrid bridge, not a one-time bulk migration tool. Direct Connect provisioning itself takes weeks, so it can't help with this timeline. The hardened box is the faster network here. Question 4. A compliance officer at a healthcare company wants a single place to define and audit backup policies across EBS volumes, RDS databases, DynamoDB tables, and EFS file systems, with daily backups and cross-region copies. Which service should they use? Option A, Amazon Web Services Backup. Option B, EBS snapshots scheduled via Event Bridge. Option C, Amazon Web Services Storage Gateway. Or Option D, RDS automated backups. Think about which constraint matters most here. This one is A. Amazon Web Services Backup is the centralized, policy-based service that orchestrates backups across many Amazon Web Services resources with cross-region and cross-account copies, purpose-built for exactly this compliance scenario. EBS snapshots via Event Bridge would only cover EBS. Storage Gateway is for on-prem hybrid scenarios, not cloud-native backup orchestration. And RDS automated backups only handle RDS. The single pane of glass is Amazon Web Services Backup. Question 5. A team plans a one-time migration of 8 petabytes of on-prem archive data into Amazon S3. Their site has limited internet bandwidth, and the transfer would take months over the network. They want to minimize cost. Which approach fits best, and what should they expect on pricing? Option A, Storage Gateway in cached volume gateway mode, with data in and data out, both free. Option B, Amazon Web Services Snowball Edge, where data transfer into S3 is free and only data out from S3 incurs transfer charges. Option C, Amazon Web Services Data Sync over a Direct Connect link, because Snowball is not supported for petabyte transfers. Or Option D, S3 File Gateway, with bandwidth automatically boosted for migrations over 1 petabyte. Lock in your answer before I give it away. It has to be B, and here's why. Snowball Edge is purpose-built for offline petabyte-scale migrations, when bandwidth is the constraint. You load the data locally and ship the appliance back to Amazon Web Services. The pricing asymmetry is the part worth memorizing. Data transfer into S3 via Snowball is free, and only egress from S3 carries transfer charges. Storage Gateway and Data Sync both move data over the wire, which is exactly what the bandwidth limit rules out. And File Gateway doesn't magically boost your bandwidth. That wraps the quiz. Well done for getting through. Next up, we'll move from storage into Amazon Web Services database services, where the same pattern applies. Pick the right tool for the job. And scene, block and file storage, EBS, EFS, FSX, Storage Gateway, Snow Family is now in your toolkit. If this beat reading the docs, you know what the like button is for. Next episode soon.